Okay, welcome back, guys. Thank you so much for supporting the channel and keep on supporting the channel. If you haven't subscribed to the channel, please do subscribe. Thank you so much for all the support that you've been giving me. Okay, today we'll be doing some proof of identities. So we'll start by proving we have this sign of 2x there. We know that thing is what is the double angle of sine. So what is we only have one double angle of sine, but cos have three different types of it. But here in sine it's gonna be 2 sine x. First of all, before I go there, you must say which side are you proving. This is my left hand side, this is my right hand side. So we'll start by saying it's my left hand side. Then from there, changing my double angle there of sine is going to be 2 sine x cos x. And then plus sine x all over double angle of cos. Now I have three types of double angle of cos. I need to choose one between the three. Now we must be careful. What do we have here? The thing that I have next to it is cos. So I mustn't put sine, because if I put the double angle that has sine, it's gonna make my things to be more complicated, because I have two, like I'm going to have two trig ratios that are gonna be different. But let's take the one that only has what? Cos. Which one is that? The one of 2 cos 2x and minus 1, then plus cos x and then plus 1. This one make things more too easy, or making things not be complicated, because if you are doing trigonometry, things, the more you do the steps, the things must become more easy, not become more complicated. Then from here I have 2 sine cos and then plus sine. The only thing that you can see here, I have sine here and also I have sine here. I hope you can see that is a common factor. Common factor of what? Of sine. So if I take sine out, I'm going to be left with 2 cos x, then plus, I took the sine as a common factor here, I'm going to left it what? With 1. Then all over here, now this one cancels this one, I'm left with 2 cos x, 2 cos squared x, and then plus cos x. Take this one here as it is, then plus 1 all over. I have cos 2x and then plus x. Then I hope you see that we have a common factor here of what? Of cos. So if I take cos out, cos of x, I'm going to left with 2 cos x, then plus 1. Now I hope you see that this cancels this, then I'm left with sine x cos x, which is just tan x. Therefore my left hand side is equals to what? My right hand side. Then we have proven our identities. Okay guys, now we're doing our second example, which is general solution. We're doing a general solution of this one here. I hope you see now here we have sine into x plus 30 and we have cos of 3x. Now from here, we know our trig ratios here are not the same. First thing that we need to do, we must make sure we make our trig ratios to be the same. How are we going to make these trig ratios to be the same? It's either we make this one or we make this one. So I prefer that we make this one, since this one contains one angle. This one is two angles that are being added. So we have sine of into x plus 30. Now I'm going to say sine, making them to be equal, but I must make sure what I'm doing here is equals to this. So if I say 90 minus 3x. Now 90 minus is on the first quadrant. Everything in the first quadrant is positive. But now, since I'm using 90, my trig ratio has to change to be cos. So it's going to be cos what? 3x, which is this one. Then from here, make my reference angle. My reference angle, which is my ref angle, is just going to be x plus 30 equals to 90 minus 3x. Now I see my sign here, it's what? It's positive. So I need to ask myself these two questions. Where sign is positive, into which quadrant sign is positive, in the first quadrant and also on what? On the second quadrant. So we know that if I'm using the first quadrant, my ref angle is my answer, I'm using it. So I'm going to say 30 x plus 30 is equals to 90 minus 3x and then plus k into 360, and then solving here, take the dropping the like terms, taking the 3x to this side, is going to be x plus 3x, and then 90, taking this 30 to the other side, it's minus 30, and then plus k into 360, and then I have 4x here. 90 minus 30, I have 60, and then plus k into 360, and then divide by 4, both sides divide by 4, and then x is equals to 60 divided by 4, I have 15, and then 360 divided by 4, I have 90. So this is my general solution, where k is an element of real numbers. And then also we said nice sign is positive on where? On the second quadrant. So you're gonna say x plus 30 is equals to, now on the second quadrant we find 180 minus, so 180 minus all these things, remember the bracket, so it's going to be 90 minus 3x and then plus k into 360, and now x plus 30 equals to 180, then this times this is just negative 90, this time this is positive 3x, and then plus k into 360, and then now adding my like terms, 180 minus 90, minus 90, it's 90, then plus k into 360, and then oh sorry, here I have what? Plus 3x, and then taking this 3x to the other side, taking 90 to the other side, I'm gonna x minus 3x is equal to 90 minus 30, and then plus k into 360, and then here I'm gonna have minus 2x, and then 90 minus 30 is 60, and then plus k into 360, then from here divide by negative 2, divide by negative 2, and then my x is equals to negative 30, then negative k into 180, where k is an element of real numbers. Thank you so much.